friends. Welcome to Solving Systems of Equations. So just some background kind of vocab stuff. The solution of a linear equation in one variable. So linear equation in one variable is something like x minus 5 equals 17. So the solution of a linear equation in one variable is the numbers that make the equation true when evaluated or plugged in for the variable. So for example, x minus 5 equals 17, the solution there would be 23, or 22, sorry. So that is a true statement when we plug it in. So 22 minus 5 should get us to 17. So our solution is numbers that make the equation true. The solution of a linear equation in two variables. Now an equation in two variables is something like y equals x minus 5. So the solution of a linear equation in two variables is the ordered pair x comma y that make the equation true when evaluated for both variables. In this case, let's say our point would be 5 comma 10 because, oops, I have that reversed, sorry, 10 comma 5. So plug in 10 for x, plug in 5 for y, that is a true statement. A system of linear equations, or a linear system. I'll use those terms interchangeably. A system of linear equations, or linear system, is a set of two or more linear equations on the same coordinate plane. The solution to a system of linear equations is the coordinate x comma y that is a solution to both equations in the system. What this means graphically is that the solution to a linear system is the point x comma y at which the lines intersect. So if we're trying to find the solution to a system of equations graphically, we have to follow a couple of steps. Whatever the equations that we're given are, we have to solve each equation for y first. We have to get y by itself on one side of the equation. Then we would graph each equation on the coordinate plane. And the solution is the intersection of both lines. So remember, this is our standard slope-intercept form equation of a line. So the slope is m. That's our rise over run. And our y-intercept is b. That's usually going to be our starting place. So to graph, in this case, y equals 2x minus 3 and y equals negative 3x plus 2, we start with the b. So in this case, negative 3, 1, 2, 3 down here. And then 2 as a slope is the same as 2 over 1. Any number is itself over 1. So our slope is actually going to be 2 over 1, which means from the point that we start at, we go up 2 and to the right 1, up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. And if we feel like continuing it all the way down, we can go down 2 to the left 1. Be careful of what order you go in, what direction. And then we draw something approximating a straight line. I didn't feel like using a ruler, I was lazy. And then we go with the other one. Let's change colors. So again, we start with our b value, in this case plus 2. So we go up to plus 2 on the y-axis. And then again, a whole number is itself over 1. So negative 3x is negative 3 over 1. So we go down 3 and to the right 1. Down 3 to the right 1. And if we want to finish it all the way up, we go up 3 to the left 1. And now we just look at what the point is that the lines intersect, which is going to be right here at 1 comma negative 1. Similarly with the other one, again we start with our y-intercept, so in this case plus 2, then we graph. Negative 1 over 3 means down 1 to the right 3, or if we're going in reverse, up 1 to the left 3, and we approximate a straight line, or y equals negative 2x minus 3, we go down 3, and that's negative 2 over 1, so down 2 to the right 1, or going in reverse, up 2 to the left 1, up 2 to the left 1, up 2 to the left 1, up 2 to the left 1. And again, we look to see where the lines intersect, which is going to be here at negative 3 comma 3. Just a couple more of these because it's been a little bit since we graphed probably. So if we are given equations where they're not already solved for y, we have to go ahead and do that ourselves. So we do that by, let's start with the first one. 2x plus y equals 1. We want to get y by itself. Oops. We want to get y by itself. So we have to get rid of the stuff on the same side of the equation as y. That means that we're going to need to subtract this 2x from both sides. Now, 1 and negative 2x are not like terms, so we kind of can't do anything more with it. We just kind of put them next to each other. But that is the y-intercept form of the first equation. Now the second one. Same idea, we got to subtract 2x from both sides to get the negative y on its own side. And again, 3 and negative 2x are not like terms, so we just put them side by side. Now finally, negative y we can't have. We need to get rid of that negative, which negative y or negative x technically means that it's negative 1 times the variable. So in order to undo it, we're going to need to divide negative 1 on each side. So y equals negative 2x divided by negative 1 plus 3 divided by negative 1, or 2x minus 3. So now these are our equations that we will go ahead and graph. So plus 1 is up here, minus 2 is negative 2 over 1. Approximate a straight line. And then minus 3, 2 over 1. So looks like our point of intersection is negative 1 comma negative 1, my mistake. Be careful that it's x comma y and not y comma x or any other variation thereof. Ignore that completely. Ignore that. And then finally, so we've got y equals x plus 2. Now, if there's no number written here, it's 1. And remember that any whole number is itself over 1. So that's technically 1 over 1x plus 2. So again, we start at 2, and then 1 over 1 is 1 up, 1 to the right, 1 up, 1 to the right, 1 up, 1 to the right, etc. And we approximate a straight line. And now we do have to solve the other one for y. So 1/2 x plus y equals 5. Subtract 1/2 x. Again, 5 and negative 1/2 x are not like terms, so we just put them side by side. So we go up to plus 5, and then we have down 1 to the right 2, down 1 to the right 2. And we see where they intersect, which is going to be the point 2, comma 4. Now hopefully the graphing and all that is starting to come back. I think we are going to take a break here. In the next video, we'll talk about the next way of finding the solution of a system of linear equations that does not involve graphing.